Even the issue of communication. How do you communicate with them if they are much more capable than we are? They might operate on a different level, a different plane. We get a mass of 33 billion tons. That's the minimum mass. The object needs to be more massive than that.
What if everything we thought we knew about comets was wrong? When astronomers first spotted 3iAtlas streaking through the darkness of space, they rushed to label it a comet, a frozen wanderer from another star system. But as the data started pouring in, the numbers didn't make sense. Its chemistry, its light signature, even the shape of its tail, none of it matched what a comet should be. This wasn't a frozen snowball burning off in sunlight. It was something else. Something colder, denser, and far stranger. Infrared readings showed almost no water vapor, the key ingredient of every known comet. Instead, 3iAtlas was spitting out massive amounts of carbon dioxide, nearly 8 times more than expected. That's like finding a campfire that burns without smoke. The physics just don't add up. Then came the polarization data. Light reflected off its dust cloud in a way no one had ever seen before. The pattern was inverted, the kind of signature that would only make sense if the surface wasn't porous ice, but something solid, metallic even. And that's when researchers started to wonder, was 3iAtlas ever a comet at all? Or had we just witnessed something completely new, maybe even artificial? Because for the first time, the scientific proof didn't point to a frozen traveler, it pointed to a mystery.
What really makes a comet a comet? So before we decide whether 3iAtlas breaks the rules, we have to know what the rules actually are. A comet is supposed to be a relic, a leftover chunk of rock, dust, and frozen gas from the dawn of a solar system. When it drifts close to a star, sunlight begins to vaporize its surface, turning solid ice into jets of gas and dust. That's what forms the glowing coma and the famous tail that always points away from the sun. Every normal comet follows the same script. As it heats up, it spews water vapor, carbon monoxide, and dust particles that scatter sunlight. Its brightness rises smoothly, its tail streams behind, and its chemical fingerprint, its spectral signature, tells scientists exactly what it's made of. Water, carbon dioxide, ammonia, a few organic molecules. Even its light behaves predictably. Under polarized filters, comet dust reflects sunlight in a distinct way, producing a consistent negative polarization curve, a reliable hallmark of porous, icy grains. It's the cosmic equivalent of a fingerprint. And the pattern doesn't change. From Halley's Comet to Borisov, every one of these frozen travelers plays by the same physical laws, same chemistry, same polarization, same evolution as they approach the sun. That's why astronomers were so confident at first. 3iAtlas looked like a comet in early images. It had a faint coma, a hazy tail, and it was following a hyperbolic path from deep space. Case closed, or so they thought. But as the instruments tuned in and the data came back, those familiar signs began to crumble one by one. Because what 3iAtlas was doing didn't just stretch the definition of a comet, it shattered it. And that's where the real story begins, when every measurement, from chemistry to light, started telling scientists that 3iAtlas wasn't playing by the rules at all.
Where 3iAtlas breaks the rules. The deeper scientists looked at 3iAtlas, the stranger it got. Every measurement that should have confirmed it was a comet instead raised more questions. First came the chemical shock. When astronomers pointed infrared spectrometers at the object, they expected to see the familiar glow of water vapor, the core signature of every comet ever studied. But 3iAtlas didn't follow the script. Its spectrum revealed an explosion of carbon dioxide, almost 8 times more than expected, and barely any water. In simple terms, it was venting gas like a dry ice machine, but with no sign of the ice that should have been fueling it. That imbalance had never been seen before.
Some scientists suggested the nucleus was coated with something, maybe rock or metal, that stopped sunlight from reaching the frozen water beneath. Others whispered it wasn't ice at all. Then came the light problem. Under polarized filters, its dust cloud reflected sunlight in a way that flipped expectations on their head. Instead of the soft negative polarization curve typical of icy comets, 3iAtlas produced an extreme negative branch, stronger than any comet or asteroid ever measured. To put it simply, the light bounced off it wrong. The data hinted at smoother, denser particles, maybe metallic grains or even glassy fragments, not the fluffy ice dust we'd expect from a melting snowball. But that wasn't the only red flag. When telescopes captured the shape of its tail, astronomers noticed something odd. Part of it was pointing toward the sun. That's not supposed to happen. A comet's tail is pushed away by solar radiation, always streaming outward. So how could this one defy basic physics? Some suggested a jet outburst, others thought it could be magnetic effects, but none of the models matched the real data. Add to that the color shift, a red slope in visible light that suddenly flattened in the infrared. That's another mismatch. Typical comets redden steadily as their dust scatters sunlight, but 3iAtlas behaved like something coated in mixed materials. Ice here, solid mineral there. By now, the checklist of comet features was falling apart. Wrong gas ratio, wrong light signature, wrong tail direction. If this were a crime scene, every piece of evidence pointed to the same verdict. Whatever 3iAtlas was, it wasn't the kind of comet we know. And once those anomalies stacked up, the theories started flying, from hidden physics to something far more controversial. Because if 3iAtlas isn't a comet, then what is it?
Alternative theories and the impossible possibilities. When you strip away every explanation that fits the data, you're left with the ones that don't, the ones that sound impossible. And that's exactly where 3iAtlas lives. Once astronomers realized its chemistry, light pattern, and tail behavior didn't match any known comet, the question shifted from what is it made of to who or what made it. The first idea to surface was the artificial origin theory. Astrophysicist Avi Loeb, known for stirring the pot with daring ideas, pointed out that 3iAtlas's motion wasn't random. Its path, brightness, and even the timing of its outgassing spikes lined up too neatly to be coincidence. Some called it the second coming of Oumuamua, another interstellar visitor that sparked debate over whether it could be an alien probe.
The object, if it's technological, it would maneuver or it would release some mini.
Loeb argued that 3iAtlas might be a fragment of engineered material, reflecting light in a way that mimicked natural behavior until you looked too closely. A hollow structure? A reflective shell? Maybe a derelict probe drifting between stars? It sounded like science fiction, but the numbers weren't laughing. Then came the dark fragment hypothesis. A few theoretical physicists proposed that 3iAtlas could be a shard of exotic matter, maybe a fragment of dark matter aggregate or ultra-dense cosmic debris that had somehow entered our solar system. That would explain its unusual mass-to-light ratio and the bizarre way it interacted with solar radiation. It also lined up with its faint, slow fade, as though it was absorbing light rather than reflecting it. Still, no one could prove it. The data it didn't behave the way it should. Another camp suggested a hybrid scenario, that 3iAtlas was once a comet, but had fused with something else during its journey through interstellar space. Maybe it collided with a metallic asteroid, encased itself in a dense crust, and carried on. Half rock, half ice, a kind of cosmic Frankenstein. That could explain the mismatched chemistry and the metallic-like polarization. But again, no single model ticked all the boxes. And behind every theory stood the same uncomfortable truth. 3iAtlas shouldn't exist, at least not like this.
Its orbit was hyperbolic, meaning it came from outside our solar system and would never return. We had one chance to study it, and we still couldn't decide what it was. To some, that's just science. Messy, uncertain, full of unanswered questions. But to others, it's a signal, a message even. If two interstellar objects in a row, Oumuamua and now 3iAtlas, both refuse to behave like natural bodies, maybe impossible isn't the right word anymore. So, is 3iAtlas truly something artificial? Or are we just witnessing a new kind of physics we don't yet understand? How strong is the not a comet case? After the headlines, the hype, and the alien theories, scientists went back to the data, because in space, numbers don't lie, unless you're reading them wrong. At first glance, 3iAtlas looked like an anomaly, but the question wasn't just what it did, it was how much those differences really mattered. Were these strange readings signs of something artificial, or just signs of how little we understand interstellar debris? Let's start with what's solid. The chemical data, those staggering CO2 levels and minimal water vapor, are real. Multiple observatories, from JWST to IRTF, confirmed it independently. That means the imbalance isn't a glitch, but there's a catch. Not every comet forms in the same environment. If 3iAtlas came from a colder, carbon-rich region of another star system, its chemistry could be perfectly natural, just alien to us. Then there's the polarization mystery. The extreme negative branch seen in its reflected light is still unmatched, but that doesn't automatically mean metal or tech. It could be the result of ultra-fine dust particles, or even a smooth icy crust that's been space-weathered for millions of years. Nature has a habit of producing weird results long before humans do. Even the sunward plume, the tail that seemed to point toward the sun, might have a mundane explanation. Some models suggest that jet outbursts, powerful bursts of gas from one side of the nucleus, could briefly flip the orientation of the dust stream. Rare, but not impossible. Still, for every normal theory that tries to close the case, another anomaly cracks it open again. Why did its brightness fluctuate so sharply, as though something was controlling its reflection? Why did its spectral slope flatten so suddenly beyond visible light? Why did its activity stop sooner than predicted, as if it had nothing left to burn? Each answer only led to new questions, and that's the beauty and the frustration of 3iAtlas. It sits on the edge of what science can explain. Too unusual to fit neatly into the comet box, but too uncertain to crown it anything else. Even the skeptics admit it. The not a comet case isn't proven, but it's not fantasy either. It's the gray zone where discovery begins, where data bends into wonder. And maybe that's why 3iAtlas matters so much. It's not about proving aliens or rewriting textbooks. It's about realizing how much we still don't know. Because if one interstellar visitor can defy everything we expect, what else could be out there, waiting to surprise us next? One thing's certain, whatever 3iAtlas truly was, it left a mark. And its mysteries might change how we look at every strange object that enters our skies from now on.
In the end, 3iAtlas didn't behave like a comet because it might never have been one. It broke every rule, from chemistry to light to motion, and left scientists staring at data that made less sense the more they studied it. Maybe it was a fragment of something older than our solar system, a frozen traveler built from materials no human has ever touched. Or maybe, just maybe, it was something built, not born. An ancient probe, a forgotten relic, a whisper from another civilization passing silently through our skies before disappearing into the dark again. Whatever the truth, one fact is undeniable. 3iAtlas challenged the limits of what we call normal. It reminded us that space is full of contradictions, and that sometimes the difference between discovery and disbelief is just one unexplained reading away. The scientists will keep arguing, the data will keep coming in, and someday maybe we'll have an answer. But until then, 3iAtlas remains exactly what makes astronomy so addictive, the chase for answers that never quite sit still. So, what do you think? Was 3iAtlas a comet that fooled the instruments, or something much bigger, something we weren't ready to recognize? Let me know what you believe down in the comments. I read every one of them. And if you love stories that dive into cosmic mysteries, hidden science, and the strange possibilities of our universe, hit that subscribe button and turn on the bell. Because what's coming next will make this story look simple. Because out there, beyond the edge of our solar system, this might have just been the first visitor.